Okay, number 36, horizontal line through -2, -1. So we can graph this out. -2, -1 is over down here in quadrant 3. And I'm a horizontal line, so straight across zero slope. Should be going through -1. Let me redraw that. So -2, -1 is here, horizontal line, and this goes straight through that y-intercept of -1. So my equation is y equals -1. A vertical line through -3, +5, that's here. And it's vertical. Oh my goodness, my drawing is just really nice today. Okay, so this has an x-intercept here at -3, so my equation is x equals -3. You cannot write these in point slope form or slope-intercept form or anything like that because we don't have a normal slope. We don't really have a rise over run. This is a zero slope. This one's an undefined slope. Okay, what's the y-intercept of the graph of the line that passes through 15, -2 and -9, 14? So I can find my equation in point slope form, then convert it into slope intercept form. So the y values, the change from -2 to 14 is 16. And the x value, I'm going from 15 down to -9. So that's going to be a negative 24. So change in y over change in x, and I can simplify that. So they're both divisible by 8. 16 divided by 8 is 2. Oh. And 24 divided by 8 is -3. So I can use either one of these points to write my equation. Y, I'll use the 15 and the -2. Y minus the y value, and then my slope, and then x minus my x value. Converting to slope-intercept form, distributing the -2/3. -2 times -15 is 30, divided by 3 is 10, subtract 2, and I get 8. Okay, so 8's my answer. So I'm going to actually put this in the graph and just make sure that it goes through these points 15, -2, and -9, 14. So let me go to my graph. New document, no, add a graph. And I'm going to graph -2/3 x plus 8. Okay, I'm going to zoom out. Okay, and it was supposed to pass through 15, -2 and -9, 14. 15, -2, yeah, probably. Let's see for sure. Control T brings up my table. 15, -2, there we go. And then it was, I forget already, -9, 14. Let's go to -9. There we go. -9, 14, perfect. Whoops. Okay. Which statement best represents a very strong linear correlation between two variables? Our linear correlation scale, 0 is no correlation, 1 is a perfect positive, -1 is a perfect negative. So very strong, I would be pretty close to 1 or pretty close to -1. The only difference between the 1 and the -1 is you'd be a perfect positive like this, and a perfect negative would have a negative slope. So we're going to say B. Okay, domain and range. This is a discrete graph, and it's just made up of points. So when I write my domain and range, I'm just going to list out all of the x's and the y's from least to greatest. So this is my x-axis right here. I start at -4, then -2, then 0, then 4, then 6. My y values, I'm going from the bottom to the top. So here's my y values. The lowest is -1, then 0, then 1, then 3, then 4. All right. Which of the tables does not represent a function? So a function fails the vertical line test. So what that means is we can't have any 2 points be right on top of each other. So it could be discrete points that are just like this. This would fail because these are right on top of each other. Or it can be a continuous graph. Like this is fine. But something like this would not be okay because it would fail the vertical line test. So we just need to see if any share an x value. So same x but different y's. So all of my x values are unique here. So it's not this one. Share same x but different y's. So that's not a function. Same x, different y's. That's not a function. And then all of these are unique. So just 2 and 3. Okay, train passengers pay $283 to ride to New Orleans. This price includes one checked piece of luggage. Each additional piece is $17. Which equation could find the cost in dollars a passenger would pay to travel with n pieces of luggage, where n is greater than or equal to 1. So we know they're bringing at least one piece of luggage. Okay. So it says each additional checked piece is 17. So I wouldn't necessarily say 17N because the first one is free. So that means that if I bought one, I would pay $17 and I'm not paying it because it's included. It doesn't subtract. You're not going to get money back. So it can't be that. So let's see. If I bring one piece of luggage, I shouldn't have to add anything. If I have one piece, that should be included. So that price should only be $283. So if I plug a 1 in for either of these ends, if I plug a 1 in here, that makes it 17 times 2 plus 283. It looks like I'm paying. I don't want to be paying. That one piece is included. So 17, if I make this 1 minus 1 plus 283, 1 minus 1 is 0. So 17 times 0 is 0. And then I'm just paying the $283. Okay, the slope of the graph represents. So remember, slope is rise over run. Excuse me. It's your change in y over your change in x. So let's find a good lattice point right there. And that looks like it's up 200 over 3. So what does that mean? As the distance increases by 200, the time increases by 3 hours.